Example 3, suppose that the population of a certain country grows at an annual rate of 20%. If we measure population in millions and time in years, okay, remember population in millions and time in years, then PT equal to P0 ERT. So in this formula, we don't know the value of P0 and also R, okay, they are still unknown. How to get those value? We need to extract from the equation. Okay, let's read this again. Suppose that the population of a certain country grows at an annual rate of 20%. So means that here we know that R is equal to 20%, the annual rate, okay? And if we transform the percentage into decimal, it equal to 0.2. So now we obtain R equal to 0.2. Okay. Question 1. If the current population is 3 million, what will the population be in 15 years? So, the information of 3 million is the P0. Now, your function can be rewritten as PT equal to P0 is 3 million, R should be replaced by 0.2 T. Now this is your complete function, Pt equal to 3 exponent 0.2 T. Question 1. What will the population be in 15 years? Since time is calculated in years, we set like this, T equal to 15, and you need to calculate your P by substituting T equal to 15 into this formula. Okay, and then you have to use your calculator. It will give you 60.26 million. So in 15 years, the population becomes 60.26 million. That is the answer for number 1. Question number 2. How long will it take? So it asks about how many years. So what is T? So that the population reach 7 million. So that P reach 7 million. And from here, we can rewrite P as 3E0.2T equal to 7. Okay, we solve this. Is 0.2T. So on the right hand side is 7 over 3, and this equal to 2.33. Now since we have this form, the single term for left and right hand side, now you can put ln on both sides. Means that the exponent can be put in front, so it becomes 0.2T ln E. On the right hand side, ln 2.33 can be calculated using your calculator, so you need to know how to press your calculator. Ln 2.33 equal to 0.8459. Ln E by the rules is equal to 1. So on the left hand side, we just have 0.2T, and on the right hand side is like that. So now you can solve your T, okay, by dividing 0.8459 to 0.2, so you obtain 4.229. And then you can write your conclusion. How long? So it takes about 4 years, okay, for the population to be 7 million. So here we solved the problem. We answered question number 1 and question number 2. Then we move to the next example. We skip example 4 for now. We will turn to this example later. Okay, we want to solve example 5. In example 5, the population of rabbits in a state was 5213 in 2020. So I want to record this information in table. So we can put year versus population of rabbit. So the first sentence state that in year 2020 the population is 5213. The next info is about rate. The population increases by 3% annually. So we can regard this as R. R equal to 3% and this equal to 0.03. So this question is a little bit challenging because in question A, you have to write your own formula. Write an exponential growth function to represent this situation. So remember that the format is like this. For growth, Pt equal to P naught 1 plus R power of t. Please follow this format, okay? So now you can put the corresponding value of P naught. P naught is the value at initial time. So we can regard this in the year 2020 population 5213 as the P naught. So P equal to 5213 and put 1 plus and your R is 0.03 t. Lastly, we need to simplify. This is 1.03 power of t. So this is the exponential growth function that we formulate, right? Again, you have to remember this format. Please use this format to formulate the problem. Okay, now question B, what will the population be in 2025? Okay, now your table will be like this. After 2020, you have 2021, and then we want to know the value in 2025. So initially means that 2020 is regarded as t equal to 0. 2021 as t equal to 1. And how about 2025? You just need to subtract 2025 minus 2020, it is 5. So by putting t equal to 5, we can calculate the population in 2025. So let's substitute when t equal to 5. The formula become 5213, 1.03 power of 5. Okay. And you can calculate, this will give you 6043. So that is the answer for number 5. Number 6. The population of fish in a lake was 73500 in 2020. So again, I want to record this info in table form. Year versus population. In year 2022, the population 73500. Due to overfishing, the population decreases by 12% annually. So here R equal to 12%. We change it into decimal points, so it equal to 0.12. Question A, write the exponential decay function to represent this situation. So the format is like this: P equal to P naught 1 minus R power of T. Here we have minus because of decrease or decay function. Okay, it is contradict with growth. If you want to formulate growth function, you must change this symbol, this operation, into addition. But for this specific case, since it is a decay function, so the format should be 1 minus R. Then let's insert the appropriate value. What is P naught? P naught is the first value, so we regard this as P naught, and this is T equal to 0. So 73500, 1 minus R is 0.12 power of T. Then we simplify this to become a complete formula. 1 minus 0.12 is 0.88 power of T. So this is your decay functions. Now let's go to question B. What will the population be in 2030? So 2022 T equal to 0, 2023 T equal to 1. And what is 2030? So you have to subtract 2030 minus 2022. It is equal to 8. So here we want to measure the population when T equal to 8. So when T equal to 8,